Hi grade 9s and welcome to WorksheetCloud Maths. I hope you're all well and you are keeping warm in this chilly weather, and if you're joining us for the first time, I hope it's not going to be the last time, because I hope you're going to enjoy this lesson as much as I enjoy giving it. Right, let's see what today holds. Okay, we're going to do transformation geometry, and as you can see, it is actually our 6th lesson in the series. If you are joining us for the first time, please feel free to go back and look at lessons 1 to 5. But let's see what we've got for today. Okay, we are going to look at reductions. That means a shape that is being made smaller from the original shape. So a reduction, is a transformation that produces an image that has the same shape as the original, but it is a different size. Okay, so it's going to have a smaller size, but it's going to be in proportion with the original shape. Okay, shapes can be reduced by what is called a scale factor. This means that each side of the original shape is reduced by the same amount. For example, a shape can be reduced by a scale of 3, a scale factor of 3. That means that the image will be a third of the size of the original one because we are reducing it. Okay, the center of reduction is the point through which the shape is reduced, and this must always be given. We will use the point of origin as the center of reduction for now, but this is not always the case. Okay, so if we start with our Cartesian plane, remember that is our x-axis and our y-axis, the x-axis being the horizontal axis and the y-axis being the vertical axis. Remember our quadrants. This one is quadrant 1, 2, 3, 4. This is where all the coordinates are positive. That's where the y-axis is positive but the x-axis is negative. This is where both are negative, and this is the other way around where the y-axis is negative and the x-axis is positive. But please remember, when we write coordinates, x always comes first. Right, so triangle HIJ is given with H being 6 and 4, I 8, 8, and J 10, 4. Okay, so there is our triangle H, I, and J. Okay, here we have 6 and 4, I up there is 8 and 8, and J is 10 and 4. Right, so triangle HIJ is reduced through the origin, through the point of origin, by the scale factor of 2. Okay, to give its image H1, J1, H1, R1, J1. Okay, or we can say that triangle HIJ is enlarged by the scale factor of a half. As you can see, if it's enlarged by a half, you actually are still making it smaller. So let's just keep to the fact that it's going to be reduced. So it's going to be reduced by 2. It means you're making it 2 times smaller. If you're enlarging it by a half, you're still making it 2 times smaller. All right. So that would be also to give its image H1, R1, J1. So there's 2 ways that you can say it. As I said there, either you are reducing it by a scale factor of 2, or you are enlarging it by a scale factor of a half. It would give you the same image. All right, so what do? Well, we have to halve each coordinate. So H1 becomes 3, 2, R1 becomes 4, 4, and J1 becomes 5, 2. Have a look at our original coordinates. Each time we've halved the coordinate. So half of 6 is 3, half of 4 is 2, half of 8 is 4, half of 8 is 4, half of 10 is 5, and half of 4 is 2. And there we have our triangle. There we have our image of triangle HIJ being triangle H1, R1, J1. Okay, and you can see we've plotted it according to these coordinates. So you will see that that is 3, 2, this one is 4, 4, and this one is 5, 2. Right, okay, so when shapes are congruent, that is the sign, remember, for congruency, that means that they are exactly the same. But when shapes are similar, that's the sign for similarity. That means they are the same shape, but not the same size. Right, so let's prove whether these 2 triangles are congruent or similar. Well, automatically we can say that triangle IHJ or HIJ is not congruent to triangle R1H1J1 because the sides are not the same length. Sorry guys, I've renamed the triangles there, but you know which triangles I'm talking about. They've got the same vertices. Okay, the sides are not the same length, so therefore they cannot be congruent. All right, but are they similar? Okay, so we've already decided. Remember, congruent means that they are exactly the same. So the same shape and they're the same size. We can see quite clearly that this one is smaller than this one, so that rules out congruency. But let's see if they are similar. All right, we can say that triangle R1H1J1 is a reduction of triangle IHJ by the scale factor of 2. Then the original shape and its image are similar figures because the ratio of any two corresponding sides is equal to K. Okay, remember K is the scale factor. So we can see that the ratio of the two corresponding sides is 2. Okay, the ratio of the perimeters is equal to K. So if we had to work out the perimeters, one would be double the other one. And the ratio of the areas is equal to K. So if we had to work out the one area and work out the other one and square it, you would see that it is equal to K. Okay, so if we say that triangle I1H1J1 is a reduction of triangle IHJ by the scale factor of 2, then the original shape and its image are similar figures because the ratio of any two corresponding sides is equal to K, the ratio of the perimeters is equal to K, the ratio of the areas is equal to K. Okay, which means that it is in proportion. Okay, because it's equal to, all of those ratios are equal to the scale factor. So it means that these shapes are in proportion to one another. They are the same shape, just different sizes. That means that they are similar. Right, so calculating the ratio of two corresponding sides, we're going to go H1J1, which is there, over HJ. And we're going to get 2 over 4. So that is the ratio of any two corresponding sides. Okay, and that will be 2 over 4. If we simplify that, it gives me a half. All right, that means this one is half the size of that one. That's why we can say that it's been enlarged by half, which actually sounds quite funny because how can you enlarge it by half? But actually, if you enlarge it by half, you're cutting it in half, or you're cutting it by half the size, or we can say we are reducing it by a scale factor of 2. Okay? Calculating the ratio of the perimeters, well, the one perimeter is 6 of this, and the other one is 12. So again, we come back to our half. Calculating the ratio of the areas, okay, we've got an area of this one being 2 and an area of this one being 8. Remember, that gives us a quarter. K squared is a quarter, so K is a half, okay, which comes back to our scale factor. So if we just do have a look at our areas, remember it's half base times height, so the half the base is 1 and the height is 2, which gives us 2. The area for this one, half base, is 2 and the height is 4, so that would give us 8. And there we have our denominator, in this case 8, and 2 over 8 gives me 1 over 4, but remember that is squared, so if we square root that, we're going to get back to our scale factor, our K, which is also a half. So actually each of these has been increased or enlarged by a half, which means it has been reduced by 2. I hope that makes sense, guys. If it doesn't, please remember to send your query to grade 9 at WorksheetCloud.com. Okay, the fact that it is a reduction by 2, it means that we've halved it. If we have an enlargement by half, it means we've halved it, basically meaning the same thing. Right, so we can say the rule is xy where half x is y, or where half it is halved to get your new xy. Okay, I hope you understand that. Right, let's look at another one. Here we've got our Cartesian plane again, and we've got a different triangle, MNO. Okay, we need to use the rule xy where our new xy is a third of the first one to reduce triangle MNO to its image triangle M1, N1, O1? Well, first of all, let's state the coordinates for MNO, because if we don't know the coordinates, we can't make up the new coordinates. So the coordinates for MNO, we're going to come to just now. After that, we're going to use that rule to work out the coordinates for each vertex of triangle M1, N1, O1. So once we've got the coordinates of this, we can then use the rule and work out the coordinates for the new triangle, for its image. Okay, and then we're going to plot triangle M1, N1, O1. So let's first state the coordinates of each vertex in MNO, triangle MNO. Okay, M is 3 and 9, N is 9 and 9, and O is 9 and 6. Okay, can you see it as a right angle triangle? It fits exactly here. So straight lines there and there on the Cartesian plane, it would mean that that was a right angle. So we are dealing with a right angle triangle here. Okay, we're now going to apply the rule, which then says that we need to work out that rule. We're going to apply that and work out the coordinates for our image of triangle MNO. So if we've got a third here, what we need to do is divide each one by 3. Okay, so we're going to go 3, 9. 3 divided by 3 is 1. 9 divided by 3 will give me 3. Then 9 divided by 3 again is 3. 9 divided by 3 is 3. So N1 would be 3, 3. And O would be 3, 2. So those are our new coordinates. And actually, I've left out the ones there. Let me just quickly fill it in. And there we filled in our coordinates. And then we had to plot triangle M1, N1, O1. And it has been plotted already. Can you see that this looks like it is a third of the size of this one? Let me just stop because I hadn't made it big enough. Right, can you see that this little triangle here, M1, N1, O1, is actually a third of the size of the original one? Okay, sorry, I skipped that quite quickly. Right, you try this now. There we have our Cartesian plane. Okay, and there we have another right angle triangle the other way. Okay, and there is the image of that triangle. So now we're going to work out differently. We're going to go backwards. Okay, work out the rule now that was used to reduce triangle RST to its image triangle R1, S1, T1. So you've been now given the two triangles. I want you to work out the rule. So pause the video now, and when we come back, we'll go through all the steps and to work out what the scale factor is, what the rule is. Okay, so there we go. Sorry guys, this is really not working out very well, but let's just try it. Okay, oh, let me stop. Sorry guys, let's try this problem again. Okay, so we've got our two triangles. We've got our triangle RST, and we've got its image R1, S1, T1. Okay, and we need to work out the rule. So I'd like you to pause the video once again, and you try and work out the rule. If you've done it already, then just hold on for a little while and we'll go over it together. Right, let's see how you did. Okay, there's our one triangle, there's our other triangle. So what we had to do was work out the rule. What you had to do was work out the rule. Okay, the first thing is going to be to calculate the ratio of two corresponding points in the shape and its image. So two corresponding points would be R as to R1, S as to S1, T as to T1. Okay, you could use any of the points. So what we're going to do is use the X in R1 and the Y in R1 and see if it works the same. So as you can see there, X in R1 is 1. Okay, so that's here. Okay, the X value is 1. When the X in R here is 2. So it's 1 over 2, which means it's a half. So the Y in R1, okay, the Y in R1 is 5, where the Y in R is 10. So it's 5 over 10. And if we simplify that, we're going to get a half, which means that basically our rule would be that it has been halved. Okay, but let's calculate the ratio of one pair of corresponding sides in the shape and its image. So remember, we put the shape at the bottom and the image at the top. And we're going to work out RS, so this side here. Okay, and we've got RS being 1, 2, 3, and R being 1, sorry guys, RS being 1, 2, 3, 4, 5, 6, okay, because that's our denominator, and R1, S1 is 1, 2, 3. So remember, we always put the original at the bottom. So that's 6. R1, S1 is 3. If we simplify that, we end up with it being a half, okay? Which means that probably our rule is a half. Okay, so we can say the rule is XY where it's made into a half. So in other words, it's a half XY. Our, how can I put it? Our image, okay, is half of the original. So what it's telling us here is that where X in the original is X, in the image it's half X. In the original, where Y is Y, in the image it is half of the original. Does that make sense, guys? I hope it does. Okay, this lesson has been quite intense. Please go back and watch from the beginning again, and you will see that actually it's not that bad if you go step by step. And one thing that I wanted to tell you is that you don't need to go through everything and work out every single thing. You don't need to work out the area and the corresponding sides and corresponding points. Basically, if you've done one of those things, you will get to your K value, which is going to give you your rule. And remember, you write the rule as it is here. You can always check it by one of the other ones. So you can either work out the perimeter, which we probably would be able to do here quite easily because this is a right angle triangle. So we've got our units across and our units down, and we can work out what the hypotenuse is by using Pythag. Okay, so you can work out the perimeter, or you could work out the area, or you could use the corresponding sides, or you could use corresponding points. Whichever one you use, I would use only one. Find what your rule is, what your K factor is, and then what you would do is you would use another one to check it. Okay, you don't have to go through every single one, but each time also use your point of origin, if that is your center point. Use your point of origin and say, is T1 half the distance away than T is? Because remember, you've halved it, you've made it smaller, you've reduced your shape. So you would always be able to do that. So you could use the T, you could use the S, or you could use the R. And if we were to look, we would say T1, what is the coordinates for T1? And you would be able to work out if it is half away from T. And as you can see there, it is, okay? Because T is 2 and 5, and T1 is 1 and 3. Sorry, 1 and 2. Okay, so it is half the way away, all right? You can use any of the points to work that out, and I'm sure you will be able to actually get this with the activity that is attached to this this lesson. Just work through it step by step rather, and if you do get confused while you're doing the activity, just come back and watch the lesson once more. Okay, so thank you so much for joining me with this lesson. I'm sorry if things did get a bit confusing with things popping up all over the place and triangles not being named in the correct way, but I hope you did get it. The reductions are just basically the opposite of the enlargements. So guys, if you wanted to, go back and watch the video that was posted before this one. I think it's Transformation Geometry 5. You can do that. Or just watch this one and go through it step by step. And remember, if you still have any queries, then to email grade9@worksheetcloud.com. Thank you so much for watching. I hope to see you again. I hope that you're going to continue to watch our Worksheet Cloud lessons and continue to enjoy maths. Keep well, and I'll see you next time. Bye-bye for now.